Alright, today we're going to talk about the very fundamentals of geometry. That is the basics. Everything in geometry is basically made out of points, lines, and planes. Alright, so what is geometry? Well, geometry is the study of space. It was discovered and used by the ancient Egyptians. The word derives from the word geo, meaning earth, and metron, which means measure. Put together, you can basically say it's the measurement of the earth. So the Egyptians, way back in the day, they used geometry for all kinds of things. And I'll give you some examples of what you can use geometry for. For example, if you take a look at that sun, and if you measure from the center of that circle to the actual circle, that's also known as a radius, we can find the measurement of the whole distance around that circle, which is also known as circumference. So there's a relationship in objects and shapes and geometry. Knowing that radius of that circle will give us the measurement of the circumference of that circle, or the distance all around that circle. Some other stuff in geometry you can use is, for example, if I can measure the side of this pyramid here, and I can measure the other side of this pyramid here, and if I measure the angle in between them, well, there is a relationship between those two sides and that angle. And if I know those two sides in that angle, then using geometry rules, I can figure out the distance of the bottom of that triangle, which we'll talk about triangles in a future date. But knowing all this stuff, you'll see that there's a relationship. And that's what geometry is. Geometry, we study the relationships between angles and sides and distances and all sorts of other stuff in geometry. So the father who revolutionized geometry was a man named Euclid. And there's a picture of him right there. He was born way long time ago. And so the geometry that we're going to study is also sometimes called Euclidean geometry. There's other types of geometry, but we're not going to get into those. The ones you're going to see here and this whole year is going to be Euclidean geometry. Alright, all objects or shapes in geometry will have dimensions. And it's not a dimension like when you probably saw the Spider-Man movies, they have different dimensions. This is not like that. Dimension in math is way different. A dimension is a measurable extent of some kind, such as length, width, or height. So let's start geometry with the basic undefined terms. Undefined terms are terms that we don't formally define, but it's said to have a meaning or a description that we all agree upon. There are three undefined terms: a point, line, and plane. And we'll use those undefined terms to make defined terms later. The first one is a point. And a point is an exact location in space. Take, for example, this box. If I were to tell you, hey, look at that top left corner of that box closest to us, then I'm talking about that specific point right there. And I mean, there's a lot of points on this box. You can think about every corner as a point in space. But it doesn't have to be just corners. It can be, for example, this point right there on that open flap. So points are labeled with a capital letter. For example, that top 3 points up there, you can choose any letter of the alphabet. Usually you'll see letters in the beginning of the alphabet like A, B, and C, but it doesn't have to be that way. For example, that first point, I can call it point A. That second point, I can call it point B. And once again, you can use any letter of the alphabet. Let's just say, for example, I wanted to not call this one C, but I can call it, for example, F or X or whatever you want to call it. We just give points names by something with the capital letter. A point has no dimension, and we talked a little bit about dimension earlier, but now I'm going to go into more detail. So no dimension means that it does not have any measurement. For example, if I were to zoom in on this box here, and I take a look at this corner here, well, what about that point? You can't really measure it. You're not going to get a ruler and say, okay, well, how much is this measure? Okay, well, like for example, this was in inches. It's not from here to here. That would be, for example, 1 inch. It's not even from here to here, which might be like 1/10 of an inch. It's from here to here, and that basically has no measurement. It's 0 feet or 0 inches. So you can't really measure points. They have no measurement whatsoever. Alright, next undefined term is a line. And the line consists of an infinite amount of points that extend in two directions without end. So there has to be an infinite amount of points. And infinite means that it's never going to stop. You're going to have a million, kajillion points that you're never going to be able to stop counting because they go on and on forever. For example, let me give you an example. If I start drawing points like this in a straight line that they kind of go on forever in both directions, then what you're going to get is you're going to get these points. They're going to get so close to each other that eventually they're going to start looking like this once you draw every single point that belongs to that line. Okay, so there's an infinite amount of points in the line, and we have to draw these arrows here to signify that it goes on in both directions. And what do we know about lines? Well, a line has one dimension because it only has one measurement, and the measurement is going to be length. Okay, I can get a ruler and measure the distance, for example, from here to here, or from here to here. And for example, if we're talking about inches, this might be 2 inches. So lines could be measured only one way, and that is only length. Okay, lines are going to have a name. You would have to choose 2 points. For example, if I get that first point there and I call it point A, and I get another point and I call it point B, then I can call this line AB, or you can just put AB like that with the line on top. Or in this case, you can also switch the letters. Order would not matter because the line that passes through A and B is the exact same line that passes through B and A. Or even sometimes, but not always, you might see a lowercase letter next to the line. If you see a lowercase letter, automatically that means it's talking about a line. So you can also name lines with the lowercase letter like so. Okay? The ones that you might see once in a while, but you're not going to very see often, is this one. You're not going to see that one. I mean, you could write line AB, but it just takes too long. Might as well just put the line on top and you're kind of done really quickly. And usually you'll see me put them in alphabetical order like this, so you might not see me doing like BA. But you do have to pick 2 points. Now here's some common misconceptions of writing a line that people get wrong. If I have a point A, you cannot call a line A like so. So you cannot use one letter. You have to use two letters or 2 points. Why? Because if you say line A and later on, let's say I have a line going through that same point, which line am I talking about? Am I talking about this line or am I talking about that line? So you cannot use one capital letter. It has to be 2 points because 2 points defines a line. Okay. And now if I say line AB, well, there's only one line that passes through that, and that would be the one that I just drew there. Okay. But this is going to be the most common way of writing or naming a line. Alright, and the last one is going to be a plane. And this is not a plane like an airplane, but a plane in geometry. It consists of an infinite amount of points that extend in all directions without end to make a flat surface. Alright, so for example, if I draw a line and then I just pretend that the screen was like a piece of paper, which is also a flat surface. And then I draw another line, and I draw another line. If I keep doing this on and on forever, what I eventually get is a flat surface like a piece of paper. Now, you gotta think of planes as that they go on forever and ever and ever. For example, here's just part of a plane that kind of goes through the earth. But just imagine if this plane or this flat surface went on and on and on infinitely, forever and forever. Alright, so a plane is going to have 2 dimensions because it has 2 types of measurements. It's going to have a length and a width. Okay, so I can measure this piece of paper, I can measure the length of it, and then I can also measure the width of this piece of paper. Then once again, this piece of paper that I have on my screen is just part of a plane. A plane does go on and on forever. And we're going to name planes with 3 points. And for example, if I call this point A, I call that point B, and I call this point C, then I can call this plane ABC. And sometimes you might see a capital kind of like italicized or even a bold, or sometimes a combination of both. Notice how that one is more bold. If you see a bold or an italicized capital letter without a point next to it, then it means a plane. Okay, so I can also call this R or plain R. Now, once again, you need 3 points. You cannot do something like this where if I have 2 points here, I cannot call this plane AB. And the reason for that is because I could draw another piece of paper that goes through this plane. For example, I can draw a plane going up and down, kind of going down this way, behind on the bottom, kind of going this way. Okay, so you cannot have 2 points. You have to have 3 points to define a plane. All right, so let's do some examples. Here we have a diagram or a picture that we're going to answer questions, and you notice we have a plane, and let's answer these questions. So for example, example A here, it says give 4 other names for line CD. Now once again, this is one way to write a line, although most of the times you're going to see a line on top of it. Okay, so line CD, and there's one way. Line CD would be this line right here, which is a line that passes through points C and D. Well, this is a line that passes through these 2 points. Okay, so I can call it line CD with the 2 arrows on top and the little line on top. Or because order doesn't matter, I can also call it line DC. Do not use 3 letters. You might be tempted to put line CED, but that's just too much. We don't need this letter here. Or I can even take off the C here and call it line ED, or you can even call it line DE. And then sometimes, like I said earlier, you might see a lowercase letter. Lowercase letters are to name lines, and because this one is next to the actual line, then you can also call this line N. Sometimes you might see people write the word out line N, but just automatically N signifies a line. Okay. All right. Example B. Give 4 other names for plane BCD. Okay. So there's only one plane, and you notice that here's B, here's C, and here's D. And so we have to have 3 points to define a plane. So how can I call this plane? I can call this plane A, like so, or I can call it plane, and the order of these points doesn't matter. As long as I pick 3 points on the plane, it's fine. For example, I can call plane EDB, or I can call it plane CDB, or I can even call it plane, and once again, order doesn't matter. I can switch these around. I can put B, D, E. There's 4 different ones. Okay. Now we're gonna get this. We're gonna get into this a little bit later. But the one you cannot call it. If you were thinking, I'm gonna put it here in the top. If you were thinking plane CED, okay, that is not one way to write a plane. These points cannot be on the same line. We'll discuss why on the next video. Okay. But because these are on the same line, once again, you can draw another plane kind of going up and down, like passes through those 3 points. So they cannot be in the same line. Okay. Once again, we'll get into that in the next video, so don't worry too much about that right now. So which line lies on the actual plane A? So once again, plane A is that one right there, which is the piece of paper that you see on the picture. And there's 2 lines. Okay. Well, the line that goes through that plane, or is on that plane, sorry, I should say, that lies on it, is this line right here, which is line CD. Okay, line CD. So line CD goes on the plane. Okay, don't say line M, which is up here, because it's not really on it, but it's kind of going through it. And you can see that it's going through it because there's little dashes. That means that it's kind of behind it, and you're not supposed to see those lines, but we just put dashes to signify that it's there, but it's not really visible. Okay. For example, D, which points lie on line N? Okay. Well, lie on means it has to be on the actual line N, which is this line right here. And there's 3 points, C, E, and D. Okay. So points C, D, and E lie on that line. For example E, it says on the picture, draw point M so that it lies on plane A. So I have to just kind of look at my plane anywhere inside the plane. I just kind of draw a point, and I can call it point M. Okay? And then for example F, it says on the picture, draw point N so that it does not lie on plane A. And so as long as you just draw it somewhere off the side, you can draw on the top, you can draw on the bottom. I'm going to draw it on the bottom here. I can call that point N, and that point kind of will be below the plane. Some more definitions here. Collinear points. So collinear points are points that lie on the same. If you had to guess, well, if you forget this later, look at the key word here. It's linear. Okay. So linear has the word line in there, and so kind of these are points that lie on the same line. Okay. And then coplanar points. Well, once again, let's look at this kind of clue here. Planar, that has the word plane in it. So coplanar points are points that lie on the same plane. And we'll see these definitions later on and some rules we talk about. But let's do an example first. So on example number 2, it says, which points are collinear? Once again, collinear means on the same line. Okay. So it depends on which line you want to look at. If you look at line M, then you can kind of say F and E are collinear. And if you look at line N, then there's 3 points that are collinear, C, E, and D. Let's just go ahead and do one of them. I'm going to do line M. So we can say F and E are collinear. For example B, it says which points are coplanar, and so it means on the same plane. Okay. Well, there's only one plane there, which is plane A. So there's actually 4 points on that plane. It's point C, point E, point D, and point B. So we can say C, E, D, and B are all coplanar. And then for example C, it says are point C and B collinear? Are point C and B on the same line? Now here's a little tricky thing. If you look at the picture, here's C and here's B, and they're not really on a line. Okay, but this is actually a trick question, because even though you might not see the line here, there does exist a line that passes through C and B that contains both of those points. So this answer would be yes. And the reason for that, once again, is because there are an infinite amount of points on this plane A here. So there's a point here, there's a point there. I mean, we're not going to sit there and draw every single point. That would be tedious and that would take forever. But there are a bunch of points here that make up a line that we didn't draw, but they are there. Okay, the ones you see up there are the ones we just decided to draw up there. And so this is, once again, a trick question. Just because you don't see it doesn't mean that it's not there. Okay? For example, I mean, there exists a line over here. Did I have to draw it? No, because you don't have to draw every single point, but there does exist an infinite points everywhere. So therefore there's an infinite amount of lines, an infinite amount of plane. But those 2 points do contain a line between them, and you just don't see them. Okay, now let's get into some more defined terms. Now that we know what a point is, what a line is, and what a plane is, now we can start defining other definitions with those definitions that we have defined already. Okay? So a segment is a part of a line that consists of 2 endpoints and all the points in between. And sometimes you might see a line segment, but I mean, that just takes forever. So I'm just going to say segment, but a segment is the same exact thing as a line segment. So if you see line segment on your homework or on your test, it's the same exact thing as a segment. And so let's take a look at, we have a line here, and if I draw 2 points, that one and that one, and if I consider those my endpoints, and I take all the points in between, only, for example, those points, then this is an example of a line segment or a segment. Excuse me. So on your picture there, let's go ahead and draw 2 points. We'll call the first one A, and we'll call the second one B. And how do I call this segment? Well, kind of like a line. You need to have 2 points, and the 2 points have to be the endpoints. So you can write out the whole word and call it segment AB, although we're not going to do that because that just takes forever. Let's take a shortcut, and you're going to see the 2 endpoints, AB, with the line on top, but you cannot put arrows, okay? Because if you put arrows, you're signifying that it's a line, and this is not a line, this is a segment. Okay? But the segment from A to B is also the exact same segment from B to A, okay? And that's it, okay? You're not going to see a lowercase letter, and most of the time you're not going to see the word segment AB, although sometimes you might see it sometimes, but most 99% of the time you're going to see it this way, okay? Once again, I like to put my stuff in alphabetical order. You might not see it that way in the books, but this is the way I do it most of the time, unless order matters. But you can also call it BA, although most of the times I'll just call it AB. Alright, and the next definition is a ray. Okay, so now a ray is also part of a line, but this time it only consists of one endpoint and all the points in on one side of the endpoint. Oh, I think I made a typo there, but that should not be there. Okay, so it just consists of one endpoint and all the points on one side of the endpoint. So for example, once again, here's a line with my 2 arrows going on forever to the left and to the right. If I draw one endpoint, well, I can look at either the left side or the right side. In this case, let's look at the right side. This is an example of a ray. Okay? And a good way to memorize a ray is kind of think of like the sun. Okay? What does the sun produce? Well, it produces sun rays. They start off with the sun, and they kind of go on forever into one direction, unless, of course, it bounces off of something. But if it doesn't bounce off of nothing, then it goes on forever in one direction. Okay? So that's like a sun ray. Think about it that way. Okay. Now for a ray, once again, you do have to have the endpoint, but you cannot just call it ray A, because if I draw a point in ray A, later on you might have 2 rays or 3 rays, and so 1 point's not going to be enough. Which ray am I talking about? Am I talking about the first one, the second one, the third one, or the fourth one? So we are going to have to use a second point somewhere in the line, or in the ray I should say, and we're going to call it B. And so you can call this ray AB, which once again, you're not really going to see it this way because it just takes too long. You're going to see it this way as ray AB. Okay. Now a ray, the order of these does matter. Okay. You cannot call this one that's up there ray BA. Okay. The one in the front or next to this endpoint has to be the starting point. And the one that has the arrow, that's the direction that the ray is going to go toward. Okay, so ray BA would actually start at point B and go towards A forever, okay, like so. And so it will be incorrect to call this one up here ray BA, because it does not start at B. It starts at A and it goes towards B in that direction forever. Okay, and then the next definition is going to be opposite rays. So opposite rays are 2 rays that share the same endpoint and form a line. Okay? So if you look at that line on the right side, let's draw one endpoint. We'll call it A. Okay? Now, opposite rays are those 2 rays, the ray going to the right and the ray going to the left. And how can we call these rays? Well, in order to call them, let's say the one to the left, I need another point going that way, and we can call that B. And so that ray going from that endpoint to the left, that way we can call it ray AB. Okay? And the opposite ray is the one going in this opposite direction. Let's pick another point and call it C. And so that point will make our other ray, AC, will be to the right. Okay, so AB and AC are opposite rays. Let me erase this part. Now let me get into a little bit of detail here, because a lot of people do make mistakes in opposite rays. The key word here is that they have to form a line. Okay, some people think that, let's say call this A, and let's say I draw a ray going up this way and a ray going this way. We'll call this first ray AB. We'll call the second one ray AC. These are not opposite rays. Why? Because they don't form a line. Okay, they might share the same endpoint, in this case point A, but they don't form a line. Okay, And so these are not opposite rays. Okay, let me give you another one. Okay, let me draw one going this way, and let me draw one going this way. Once again, they look like opposite rays because people think, hey, they're opposite rays because they're going in opposite directions. But that's not true because they don't form a line. These are just two rays going in opposite directions. So they're not considered opposite rays. Let's look at the last example here, number 3. For A, it says give another name for segment FG. Okay. So on the picture, let's look at FG here. It's talking about this piece right here. And so I'm going to actually give you two names. We can call this FG with the segment bar on top. So that's segment FG. Or because order does not matter, we can also call it segment GF. For example B, it says name two different segments on the dark plane. There are segments everywhere. Although we didn't draw a bunch of segments. I mean, I could draw a segment on this here and there. But the ones that you can visibly see is this one here. Only the piece from J to G or from G to J, that is one segment. And even though you don't see this little segment here, but there does exist a bunch of points here that we just didn't draw out. And that will be a segment there, JK. So we can also say segment JK. C. Name 3 different rays on the white plane. Okay. So we can think about starting at G, going towards E. We can call that ray GE. Or I can think about the opposite ray, G, going towards F this way. Make sure you put one arrow to signify it's a ray. If you don't put those arrows, then we're talking about segments like in example B. So you have to put the arrows to signify that they are rays. Okay? And then you can also think about this ray here from G going to I. You can also go that way. That's also another ray. And then for example D, it says name a pair of opposite rays. And so there's a lot of opposite rays on this thing. I'm going to go this way, GH, and I'm going to go in the opposite direction, GI. Okay, notice that both of those together make a straight line. Okay, so GH and GI are opposite rays. All right, for example E, it says which planes contains point H. Okay, so here's point H, and you can kind of tell right there that both of those planes contain point H. So if I look at the white plane, I need to pick 3 points on the white plane to call that plane or to name that plane. So I'm going to pick 3 points. And once again, those points cannot be on the same line. Okay, so if I pick H, I can pick, like, for example, E, and I can also pick, for example, F. So I can call it HEF. But also the dark plane also has this point H on it. So as long as I pick 3 points on the dark plane that are not on the same line, okay, HJK. So I can call it plane HJK. Okay. Now some of you guys might be thinking, can I call either one of those planes plane HGI? Okay. HGI. No, you cannot. Okay. Why? Because those are all on the same line. And if I say plane HGI, am I talking about the white plane or am I talking about the dark plane? Well, you wouldn't know, okay? That's why when you name a plane, you cannot pick 3 points that are collinear. They have to be not on the same line or non-collinear. All right, and for the last example here, it says REG, or I should say ray EG, and ray FG, opposite rays. So remember, they're going to be opposite rays if they make a straight line. So if I look at EG, E is going to start here, and it's going to go that way forever. Okay. And I'm going to use a different color here. Let's use blue. Okay. If I draw FG, it has to start at F, and it has to go this way. And you might be thinking, yes, these are opposite rays. Why? Well, because they make a line. Okay, if this goes on to the left forever, and this goes on to the right forever. But the thing is that in order for them to be opposite rays, they have to have the same endpoint. And this one has an endpoint of E, and this one has an endpoint on F, and so the answer here would be no. Okay, they have to kind of, once again, one has to start this way, and the other one has to go in this opposite direction, but it has to have the same endpoint. All right, and that concludes our first lesson on points, lines, and planes.